Okay, hi, grade eights. So now we are on to page, we're still on page 386. 386, and this is number 15. It talks about someone who has double the money that she has in her account. I assume that's a bank account. And then she took out $50, but she still would have enough left to buy a new bike. Okay, so again, not going to do your question for you, but I'm happy to do a fake question. You're welcome. If Lily tripled the money, so this is my fake question. If Lily tripled the money, yeah, that's different from doubled. If Lily tripled the money she has in her bank account now, then she took out 80, she would still have enough left in her account to buy a bike that costs $429. Write and solve an equation to determine how much money. That's supposed to read Lily. So you see how I just try to make up questions. So this is supposed to be Lily. Hi, Lily. That's a big I now. So determine how much money Lily has now. Okay, so if Lily tripled, there you go. Now, when I see tripled, I think of 3 times. 3 times my money. So in other words, if I started with $10 and I tripled it, now I've got $30, right? Maybe I did well on the stock market, okay? Or maybe I invested in a quarantine lemonade stand and everything cost me $10, but I made 30. Anyways, if I had $50 and I tripled it, now I'd have 150. If I had $200 and I tripled it, it'd be 600, and so on and so on. So tripling your money basically means to times it by 3. Lily tripled her money that she has in her bank account now. Do we know how much Lily has in her bank account now? Do we know? No. We don't know. We don't know. Okay. So this is where this little trading that I've tried to teach my grade 8s and grade 9s in particular, this is where you want to use this very famous statement. Okay. In other words, we're identifying what we don't know. We're identifying the variable. We're identifying what we need to solve. You see, I'm like dilemma over what color I should use because it's an important thing. Can I make it a little bit bigger? Yeah, there we go. So we're going to say this. We're going to use this very famous quote. Let X. Now, I don't care if you want to use A for amount, whatever, D for dollars, I don't care. Obviously, we're going to use our classic stereotypical variable of X. Let X equal the amount of money Lily had in the bank account. Okay. Now we're saying we're trying to find out how much money she had before she tripled it, before she took out the what did I say? She took out $80. Okay. So I'm just going to decrease this again. All right, and we'll do pink. So we've identified the variable. We're talking about what we don't know. We don't know how much she had in her bank account now. In bank account now, I should maybe add that, okay? Because we're not talking about when later she tripled it and when later she took out the $80. We're talking about how much did she have in her bank account now. We don't know it, okay? Now, she still had enough left in her account to buy a bike that costs $429. Okay, so we've got some numbers here to play with, all right? We've got 3 times, and we've got 80, and we've got $429, all right? Now, there's a little bit of assumptions going on here, all right? It doesn't tell us how much money she had left over, okay? In other words, even after she goes to the bike, we're assuming she's spending all of her money. In other words, this should end up at being all of her money is going to leave her account. So first of all, this happened. She tripled her money. Second of all, she took out $80. We have no idea what she did with the $80. No idea. Maybe she bought, I don't know, new headphones or something. Who knows? All we know is that, number 1, she tripled her money. Number 2, then she took out 80, and then that led to a little action item number 3, which is she still had enough left over to buy a bike that was $429. And let's assume that that $429 is going to suck up all the rest of her savings, okay? So then let's talk about an equation. So an equation would look like this. So let's talk about the equation. All right. So she has this much money in her account now, all right? So when you don't move, when you say stay planted in your seat for like, 5-10 minutes, the lights go out in your classroom. The lights go out. So I'm just going to pause and turn the lights back on. Actually, the video looks fairly fine. Yeah, I'm going to leave it. Whatever. Who cares? All right. So she started with X amount of dollars. She tripled it. Lily tripled it. So why don't we just attach or glue 3 as a coefficient to X? Because this number always implies multiplying, right? The coefficient of X is always multiplying. Even if it was a fraction, even if it was a decimal, doesn't matter. As soon as you slap another, like X by itself means 1X, 1 times X. So what we're saying is we're very flexible. We don't have to always have 1 times X, right? We don't. You can have numbers that are attached to X that are different from 1. So 3X, and then look what's happened. She took out. If we want to say, when you say you took out money, does that suggest to you someone is adding or subtracting? Well, to my mind, when money goes away, whether it's spending or whether you're just withdrawing it from the bank account, you're taking it from your bank account, I would say it's subtraction, okay? Now, even after all of this happened, this amount would still have to equal $429 because it says so. She still has enough left in her account to buy a bike that has $429, okay? So we have built our equation. All right. And this is where normally in a live class, I would pause because it's really important for you to know so you need to know how to build. Okay. I would suggest to you, this is the most challenging issue of word problems. Students have to take the information they're given here, and then they have to sort of unpack it and interpret it and then analyze it. And then figure out how they're going to glue everything together and create and construct some sort of meaningful sentence in math, right? We go from English to math. That's what we've done here. Okay. So at this point, right, here's your coefficient. I'm going to keep using this language because you know what, grade 8s, you need to know this language cold anyways for next year. This constants, okay? Constants are always separated by either addition or subtraction. In this case, it's subtraction. When we go to, again, we're working BEDMAS backwards. So let's just write that out as a little reminder over here. BEDMAS backwards. So that's why coefficients are always playing in this sandbox. They're either addition or subtraction. And then so we do them first. We deal with these because eventually we want this to read X equals. That kind of implies Mr. Smith will have to do something with this 3. We'll have to do something with the subtraction of 80. So I'll just leave it in blue. I'll add 80 to both sides. And by the way, I picked 429s, and I don't know how nicely this number works out, but yeah, we'll see. Okay. In other words, X may have a decimal is what I'm saying because I just made this question up on the spot. This zeroes itself out, which is phenomenal. We always want it to zero out. We added 80 to both sides, so that is 509. Oh, I came so close to making this work. Too bad that wasn't 510. Whatever. All right, so we're going to divide both sides by 3, right? 3 multiplied to X, that's the relationship, multiply. So we're going to divide. We're always working backwards. Always do the opposite. Whatever the relationship of these numbers is to X, we do the opposite, because we want to work backwards. And so whatever we do to the opposite to the X, we do the opposite on the other side. So we have to divide both sides by 3. And here, okay, I've tried to remind you, 6,822 times. The 3 over 3's do not cancel to a 0. They don't go to a 0. The 3 over 3 reduces to a 1, which is awesome. We got 1x now. Now, 509 divided by 3. I don't even have my calculator handy, so it's time to, get the rust off. I already knew that this is too bad it's not 510 because I know what the answer would have been. But anyways, I know that 160 will go onto this. So this is 480. That's not a 9, that's a 4. 480. Okay, so 9. And 50 minus 48 is 2. So you see, if this had been 30, it would have been 10 more. It would have been 170. But, whatever. So 9 times 3 is 27. And this remainder is 2. So now we can introduce a decimal. And we can say bring down a 0. And this will be 6. And that'll be 18. And I know from experience of doing 6,000 of these, there's always going to be a remainder of 2. Oftentimes when you divide by 6, you get these repeating decimals. Okay, so basically, in other words, Lily would have started out with $169.66. Okay, I guess I could just show that's repeating. Okay, and then she tripled it. And then she took out 80, and she still has a bike that costs $429. In fact, you know what? I'll just show this. To check. Watch this. So to check, I actually will round this up. Let's just pretend Lily had $170. Okay. Step 1. She tripled it. Holy mackerel. I think my tablet pen needs to be, it's like the smart board. It needs to be realigned. She tripled it. So if someone triples their money at 170, they get $510. Now, if they took out $510, step 2 was they withdrew 80. So when they withdraw 80, they're left with 430. That's not a 9, that's a 4. They're left with 430. Okay? And 430 is close enough to 429. So we got the answer, okay? We got the answer. All right, so anyways, Lily started with $169.66, tripled it, took out 80, still enough money left over to buy a $429 bike. Okay, guys, that's it for this one. And then I'll come back and I'll do 17, all right? See you soon.